Hello everyone, myself Pinky Sherpa and my topic for this video is Astronomical Telescope. First of all, before going to Astronomical Telescope, let us understand what is telescope. It is an instrument that is used to view distinct objects by means of the refraction of light rays through a lens or the reflection of light rays. Telescopes are of different types. Mostly telescopes are classified by refractors, reflectors or compound scopes, which used a combination of both lens and mirror. And under this category, there comes astronomical telescope. So, as you can see from the definition, astronomical telescope, it is a device which is used for observing distant images of heavenly bodies like stars, planets, etc. As you can see from the name itself, it is related to astrology. So now let's see its theory. So it has two convex lenses separated by same distance. The lens towards the object is called objective lens. The lens towards the eye is called eye lens. Objective lens has higher aperture than eyepiece or eye lens. So now this astronomical telescope, in this astronomical telescope there is two cases. One is image is formed at infinity and other is image is formed at near point. So first of all, let's see image is formed at infinity. First of all, to describe this we need a ray diagram. So let us first make a principal axis and an objective lens which has bigger aperture and an eyepiece which is smaller aperture. So when the image is formed at infinity, obviously the object is also at infinity, and when the object is at infinity, the rays comes in parallel. So first of all, let's give this OPG, objective lens and eye lens. So here is our eye. Now let's make now when the object is at infinity, the rays comes in parallel. So the first ray and the second ray, the third ray. Let's give this center point C1 and C2. As we all know, when a ray passes through the center of the lens, it goes directly without any deflection. As we can see, when the rays meet in a point, there forms an image. Let's give this A dash, B dash. Now, as we can see, when the rays passes through an objective lens, it forms a small and inverted image. So now, let's pass this rays through eye lens. as the length from objective lens to the image formed by objective lens. The distance between it is FO, and the distance from the image formed by objective lens to the eyepiece is FE. Now, as you can see, magnification. It is defined as the ratio of an angle subtended by image to the angle subtended by the object on eye. So to find out the magnification, we need the angles that is subtended by the image to the angle subtended by an object on an eye. So first, let us find out the angles that is subtended by image to the angle subtended to the object on eye. So first angle that is subtended, over here, that is beta, and the second angle is over here, that is alpha. So through this ray diagram, let's find out the magnification. M is equals to beta by alpha. So this is the magnification that has come out from the definition. So as we can see that for small angle, we can write M is equals to tan beta by tan alpha. So now as we can see that tan beta, which is over here, it lies in a triangle A dash, B dash and C2. So as we all know that tan theta is equals to perpendicular by base, so which becomes M is equals to tan beta. So its perpendicular is A dash, B dash. So we can write A dash, B dash by, and its base is A dash C2. On the same way, as we can see tan alpha, as we can see the angle alpha is over here. So as we all know that vertically opposite angle are equal, so we can give an alpha over here. As we can see now, tan alpha is in the triangle A dash, B dash and C1. So in the same way, tan alpha becomes A dash, B dash by C2. So as we can see over here, A dash, B dash and get cancels. So C1. So the remaining is C1 by C2. So now, as we already have given the length of C1 to B dash is FO and B dash to C2 is FE. So we can give over here M is equals to FO by FE. Therefore, this is the magnification when the image is formed at infinity. Now, length of the tube. As you can see over here, it is described as the distance between objective lens and eye lens, which is, as you can see, this is the objective lens and this is the eye lens. So length of the tube or telescope means the length between the objective lens and eye lens. So let length of the tube be L, so which is, as you can see, the length from objective lens to the image is FO and the length from image to eye lens is FE. So simple, it will be L is equals to FO plus FE. Now we have finished the case 1, which was image is formed at infinity. Now the case 2, where the image is formed at near point. So let's first draw its ray diagram. So this is the principal axis and this is the objective lens, which is larger aperture, and this is the eye lens or eyepiece, which is smaller aperture than objective lens. So now as we can see, if the image is formed at near point or whether image is formed at infinity, the object is obviously gonna be at infinity because it is of astronomical telescope. As you all know that astronomical telescope is mainly used to observe heavenly bodies like stars and planets. So obviously the object is gonna be at infinity. So let's give the center point as C1 and this as C2. So when let this be the rays that is coming from the object. As I have already told you, the rays that has passed to the center goes directly straight and let this be the image formed by the objective lens, which will be A dash and B dash. As you can see over here, it is till this point it is same as the first ray diagram. As we can see that we can see that we have same till to point here we have same, but we can see we have taken the focal length over here so that the image can be formed at infinity. But we cannot do here. If we do it as the same as the first ray diagram, our image will definitely be formed at infinity. But to form the image at near point, we must change our FE. So to change our FE, we can take our eye lens over here so that our FE will be over here. Otherwise, we can take objective lens quite back so that the FO will be back. So to make the image formed at near point, let's keep our focal over here FE. As to make an image does not formed at infinity, we must keep object at center and focus. So here is our eye. When let's say this ray passed to the center of the eyepiece, and when a line parallelly comes to a lens, it is deflected towards FE, focal length. As we can see over here, the image will be formed over here. So this is the final image that is formed by the eyepiece. This is the objective lens and this is the eye lens. As you can see, the image is formed at a near point, which is over here. So let's the distance between the final image to the eyepiece be D, and let this be A, B. Now, as we all know that that magnification, it is defined as the ratio of angle subtended by the image to the angle subtended by the object on eye. So to find the magnification, first we must find the angle. So the angle beta is over here and the angle alpha is over here. As I have already told you, the vertically opposite angle are equal, so another alpha angle will be over here. So now let's find out the magnification for image is formed at near point. Therefore, M is equals to tan beta by tan alpha. So it is similarly to this ray diagram, as we can see. So now let's give tan beta, which is in the triangle A dash, B dash and C2. So therefore A dash B dash by A dash C2, and tan alpha, which is in A dash B dash and C1. Therefore A dash B dash by B dash C1. Similarly, this and this get cancelled, which remains B dash C1 by B dash C2. As we can see, it is similarly to the ray diagram where the image is formed at infinity. But over here, let's keep this length between the objective lens to the image be FO. Now, the length from this image to the eye lens will be given as UE. So, which becomes, my magnification will be M is equals to FO by UE. So this is the magnification where the image is formed at near point. Now, according to lens formula, and this is for eyepiece. So as you all know the lens maker formula, which is 1 by f is equals to 1 by v minus 1 by u. So from the so now as we can see from the ray diagram, f, our focal length is fe, and our v is, which is d, but v minus t, our u is minus ue. So from here we can 1 by fe plus 1 by d equals to 1 by ue. And when we take the common from here, which is 1 by fe, so the remainings are 1 plus fe by d equals to 1 by ue. So now as we have found the value of 1 by ue, now let's put this value in the magnification formula, which will be m is equals to fo into 1 by minus ue. So the putting the value of 1 minus u in the formula, magnification formula, it becomes fo into 1 minus fe 1 plus fe by d. Now m is equals to fo minus fe 1 plus fe by d. So this becomes the another magnification formula for image at near point. As we have got the two magnification formula, this and this, we mainly use this formula, but when we are not given UE, we can use this formula. So now the length of the telescope for image at near point will be length of tube or telescope will be L is equals to FO plus UE. And now the last topic for this video will be advantages and disadvantages of astronomical telescope. The first, advantages. There are various advantages of astronomical telescope, and some of them are: it creates large magnification, superior resolving power per inch of aperture, it fills a view is wide, superior performance in interior conditions, the image is free from abbreviation, not reflection or interruption of the light path. And last one, long focal ratios can mean the use of longer focus, simpler eyepiece. This will be the advantages of astronomical telescope. Now, disadvantages of astronomical telescope. A certain amount of secondary spectrum unavoidable. Long focal ratios can mean that the instrument is cumbersome, which means that because the astronomical telescope is very large, which can be very troublesome to carry it. As the main tube is very long, so the instrument becomes quite large. as an inverted image is formed in this instrument, so it is not usable for observing objects at long distance in front of the Earth's surface. As you can see, this is the advantages and disadvantages of astronomical telescope. And now, as from all of this, telescope has played a vital role in our human life, because without it we would not have seen the outer space. It is an instrument that has given a vast knowledge about the space. So with this, I would like to end this video, and thank you.